Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Welcome to our vlog. My name is Manisa Sakiagni.
My name is Kirana Syarifaini.
We are from 11 Science 2 and we are going to talk about carbonyl compound. So first, we are going to explain to you what is carbonyl compound and also two kinds of it. Aldehyde is a compound that contains carbonyl group attached to a hydrogen atom or two. Ketone is an organic compound that has a carbonyl group on three alkyl groups.
The next one will be the IUPAC name of aldehyde and ketone. The first one is aldehyde. The IUPAC name of aldehyde is called alkanal. The suffix from it is -al. The example is methanol, ethanol, propanol, and etc. The second one is ketone. The IUPAC name of ketone is alkanone. The suffix is -one, 1. The example of it is methanol, ethanol, propanol, and etc.
Aldehydes are compounds in which the carbonyl group is attached to an alkyl or aryl group. The formula is RCOH. Ketones are compounds in which the carbonyl group is bonded by two alkyl or aryl groups. The formula is RCOR. And this is formula of aldehyde and ketone.
Alright, why would we say aldehyde and ketone are called as carbonyl compound? As the first one that we already discussed, we know that aldehyde and ketones are organic compounds which incorporate a carbonyl functional group which is C bonded with oxygen. The only difference is in aldehyde, the carbonyl group bond with hydrogen, and in ketone, the carbonyl group bond with carbon-containing substituent.
The IUPAC nomenclature on ketones only replaces the suffix "a" in alkanes with "on" for ketones with the same number of carbon chains. For example, if the alkane contains propan, it is read as propanol. The IUPAC nomenclature for aldehyde compounds is to change the suffix in the alkanes with for the aldehyde with the same carbon chain length. For example, if the alkane contains ethane, then an aldehyde with the same carbon chain length or two carbon atoms is called ethanol. And this is nomenclature of aldehyde.
Nomenclature of aldehyde. Step 1. Position of COH or functional group always on the H and get number 1. Step 2. Write the side chain alphabetically. Step 3. Numbering always start from functional group. And step 4. End of name of main chain is al. Nomenclature of ketone. Step 1. Functional group or carbonyl always get the smallest number. Step 2. Write the side chain alphabetically. Step 3. Number of carbonyl compounds position is state. Step 4. Main chain should be ended by 1. The next one is how to deduce the isomer of carbonyl group. Step 1. Identify the formula. If it's CnH2n plus 1O, it is aldehyde and ketone. Step 2. Deduce all the isomer of aldehyde. And step 3. Deduce all the isomer of ketone. The final step is totaling the number of both isomer. As example, I take C5H10O as the compound. Is it satisfies the formula CnH2nO? Yes, it is. So, it has an aldehyde isomer and ketone isomer. The aldehyde isomers are pentanal, 3-methylbutanol, 2,2-dimethylpropanol, and 2-methylbutanol. The ketone isomers are 2-pentanone, 3-pentanone, and 3-methylbutanone. So, the total of isomers of C5H10O is 7 isomer.
And this is primary alcohol. Distillation removes the aldehyde and process it from further oxidation. And this is aldehyde hydride, secondary alcohol, heating under reflux, and ketone no further oxidation due to lack of the respective C-H bond found in aldehydes.
The second reaction of aldehyde and ketones are reduction. If I want to make an alcohol from aldehyde and ketone, I will use a reducing agent which is NaBH4 or LiAlH4. If I use aldehyde and plus the reducing agent, I will get the primary alcohol. And if I use ketone with the reducing agent, I will have the secondary alcohol. The third reaction is an addition of hydrogen cyanide or HCN. Aldehyde and ketones undergo reaction with HCN to produce cyanohydrins. The reaction progresses very slowly by using pure hydrogen cyanide. Hence, base as a catalyst helps to speed up the reaction. This is because catalyst helps in the generation of cyanide ion or CN, which acts as a stronger nucleophile and adds to carbonyl compounds to produce the corresponding cyanohydrin. Due to electronegativity difference in carbon atoms and oxygen atoms, the carbon-oxygen bonds demonstrates a polar behavior. This, in turn, results in gaining a partial negative charge on the oxygen atom and partial positive charge on the carbon atom. The partial positive charge of the carbon atom will attract cyanide ion of H plus Cn minus. The double bond of carbon-oxygen will break and a new carbon-Cn bond occurs. Furthermore, the unstable oxygen will attract the H plus of hydrogen cyanide.
The addition of water to an aldehyde results in the formation of a hydride. The formation of a hydride process via a nucleophilic addition mechanism. 1. Water acting as a nucleophilic is attracted to the partially positive carbon of the carbonyl group, generating an oxonium ion. The oxonium ion liberates a hydrogen ion that is picked up by the oxygen anion in an acid-base reaction. To determine the presence of carbonyl compounds can be added at room temperature. A positive test is an observation of orange deposits. Carbonyl compound test an observation. We need to know the sulfur means DNPH structure to write a balanced equation, and it's easier to remember the full name and the structure together. The full name of 2,4 means DNPH or British region is 2 = 4 dinitropene dehydrogenase. To break down functional groups, the nitro means NO2, phenyl is benzene, hydrogen is NH2 minus NH2. So we can put them all together to make the structure of 2,4 means dinitrocyanide. That's the structure of the 2,4-DNPH carbonyl compound. Type of reaction: condensation. The reaction between the carbonyl compound and 2,4 means DNPH pH is a reaction in which the two compounds combine and the small molecule H2O is eliminated. To draw the product easily, we can point the carbonyl functional group towards the hydrazine functional group, pick the water, and join the two fragments through the C and bond. The product with a C and bond is an amine functional group, and this gives a distinct orange color indicating the presence of a carbonyl functional group. Thus, for the condensation reaction of carbonyl compounds.
The second critical thinking. According to EcoGreen, the compound that is used to destroy styrofoam is what? I think it's acetone. Because specific molecular interaction between styrofoam with some organic liquid such as acetone can dissolve the PS form. Why? The interaction between a polymer and a liquid depends on their cohesive energy densities, or CED, which is related to polarity or non-polarity of the molecules. In order to be able to dissolve a polymer, the liquid must have an HSP value close to that the polymer. For instance, the CED values of PS and acetone are 9.13 and 9.77 respectively. Considering these close values, it is expected that acetone perfectly dissolves the PS. The last one that we will discuss is the example of carbonyl compound. First, there's a famous ketone named methadone, helps in curing addiction of opiates such as heroin, opium, and morphine. The second one is acetone, acts as a paint thinner and a nail paint remover. The third one is ketone, behaves as an excellent solvent for certain types of plastics and synthetic fibers. The fourth, formaldehyde, reacts with phenol, forms a compound bakelite, and bakelite finds its application in plastic coating and adhesives. The fifth one will be benzaldehyde or aldehyde is an essential component for the production of perfumes, cosmetic products, and dyes. That is all from us. Wassalamualaikum.